So today we're meeting Albrecht Smith, who is a professor in pervasive computing and user interface engineering at Duisburg Essen University in Germany. And for many years, Albrecht has been doing research and designing products using context-aware computing. So he's the ideal person to tell us about how we can apply these principles when designing products. So, Albrecht, can you name your main guidelines which we can use when we work successfully to design products?
I think the main guideline for creating context-aware technologies and context-aware user interfaces is simplicity, like for so many things in user interfaces. And I think the guiding principle for designing such systems should be how you can ease the use of the device by using perception, sensing, and context awareness in the device. So as a designer, you should always look, what do people have to do in order to operate the device, to use the system, and whatever you can sort of automate away of the boring parts, you should do. And be it something like, if you take a device and when you hold it in a certain position, then you can recognize this position, and there is no need for the user to explicitly tell that he wants to phone now. So things like function follows usage on an automated way. That's one example. So I think the main guiding principle is to use context awareness as a resource to make things easier to use. And now looking at how we do this specifically, we can first we should figure out what sensors give us information about the real world, which is interesting with regard to the problem we solve. So if we build a system that should be reactive to the number of people around or to who is around, we obviously need sensors to figure out who is around. And this may be a sensor for Bluetooth to detect the devices of the other people. It may be a camera who recognizes the people. So I think we should first think what information can help us to ease the task of the user with the system, to make it easier to use it. And when we know what information we need, we should then look what sensors can we employ, what sensors can we use to get this information into the system. And when we have this information, then how can we match it to those situations we wanna recognize? This is sort of on the sensing side, a very straightforward way of doing it. On the output side, we should have as a guiding principle to minimize the cost of error. And so, for example, when you can have, let's assume you want to build a mobile phone which has sort of the most likely contacts you want to call, very easy to access. So you can always guess what is the most likely person to call. Probably in the evening it's a different person than at 11 in the morning. But it's probably pretty hard to guess that person from the data you have. So here, to minimize the cost, it would be that you have sort of 5 or 6 names which you can easily recognize on that screen, and very easy access to the phone book, so that the cost for having this function is not more than just having the link to the phone book. So if you then guessed one of the people right, of those 5 or 6 you show, then you saved the user some time, you made it easier to use. And if you guessed wrong, you didn't increase the effort the person has to have to go into the telephone book and to look up that name. So I think there's the central principle. If the system doesn't get it right, which it may from time to time, that it doesn't really hurt the user. So we should try really to build the systems, the user interfaces, in a way that we gain from context awareness, but we don't lose out if context awareness goes wrong. That's why I think it's important also to look mainly for applications that really have this property that with context awareness you can gain, but if it gets wrong, nothing bad will happen. So I think the things to avoid are critical systems, where if you guess right, it's good, but if you guess wrong, it's a disaster. So I would leave those away. This is sort of the way if you design it from scratch. You think what information from the real world you need, then you think what are the right sensors to do this, and then you build a system which adapts the user interface to that. Very often it's also the other way around for a designer. You get a device, or you come into an environment and there are certain sensors. So at the moment you buy a mobile phone, and on that mobile phone there is an accelerometer, there is a magnetometer, like an electronic compass, there is a light sensor, there is a camera, there is a microphone. So you have a fixed set of sensors, and you're typically not in a position, if you have an idea for an application, to call up all the 5 or 6 big hardware vendors and say, oh, can you please in your next version of a mobile phone include this sensor or that sensor? They will probably say, yeah, call again some later time, and they won't do it. But very often then you have the set of sensors given, and then it comes to a point where you can sort of think what you can do with certain sensors. And it's interesting, a given sensor has obviously a typical purpose, but you can be creative in the way you use sensors. So if you look in the literature, you will find people using temperature sensors to monitor if people come into a room or not. It's a very cheap sensor, but if a number of people come, the temperature will rise. Or if people hold the device in the hand, they will also sort of hold it in a certain way, and you will get an increase in temperature. And it's very likely that, for example, the camera will be covered if it's at a certain point, depending on the device. So you can really use the sensors which are available to get information you're interested in, and then that changes that first part of getting the information. So you take the sensors you have available and you be creative to get this information out of those sensors and get them as part of the application, get the information of the task.
Would it be possible to mention all the types of sensors we have right now?
Not really. I have been some years back at a sensor fair. Because I think when I did my PhD, I thought, oh, let's do sort of like, you look in PhD always for big things. Mm-hmm. So I thought, let me do a sensor classification, and just to figure out that other people did sensor classifications. But usually it's a very big book with a lot of sensors. So I think being complete with sensors is probably very, very difficult. So you could probably list them, but it would be a very, very boring next hour. So I wouldn't want to go into that. But it's very simple. There is a set of sensors out there which we find in devices, and there are further sensors which you can build into devices. And I think the most common ones currently used are camera and microphone. So it's vision and hearing, and that's interesting. It's also a link to the human perception. Further sensors we see are temperature, again linked somehow to what humans experience. Then we have things like sensors that detect motion, movement, handling of devices like accelerometers or magnetometers. They are quite common in devices nowadays. Further sensors which go then beyond what humans perceive are things like GPS, so basically getting the location for the user. And those are sort of very typical sensors. In research, we see at the moment people experimenting a lot with capacitive sensing in clothes. So I've recently read a paper where somebody built a collar which you can put around your neck, and you can estimate what people drink, eat, and figure that out. You can have stretch sensors in clothing, which gives you an idea of the body movement of a person, and hence you can estimate what activities they are doing. So there's a whole range of sensors, and I think my advice here would be, if you need a certain information, it's very likely that there is a sensor out to do that. So then go into a sensor catalog and look what sensors are out there. And then the interesting question is often, perhaps the sensor is not described to bring you this information, but if you are sort of a bit creative on the usage of the sensor, you may be able to have a certain sensor which is made for something different to give you this information. As I mentioned, you can use a temperature sensor to detect people. And there is also an interesting point that very often using one sensor, detecting something is very difficult. Using multiple sensors, it becomes easier. So take the situation here, we're sitting 2 people, we are talking, and probably detecting that there are two people is not too difficult because it's a male voice and a female voice, but it would be harder if we have sort of, if we would be twins, have similar voices. But the moment you would put up 2 or 3 microphones in this room, it would be completely trivial to estimate how many people are there. So with very, very little computation. So I think, and that's what we see where sort of new ideas come in the way people use sensors and also do the detection of certain contexts. So there is also sort of room for new products, new ideas out there.
But how do you come up with ideas for new products?
Yeah, the idea where what sensors to use, it may be driven from different directions. So one is really from the need. So there is an adaptation which you each time do yourself, like filling in the time when you stored something. And then you just come up, oh, this could be automated. But I think a very interesting thing, which I reflected more on recently, is sort of looking into nature. In nature, perception is one of the things that is really defining for intelligent behavior. So to be smart, to be intelligent in a real environment, animals, plants adapt and sort of react to their environment. And in the struggle for survival, adaptation to environmental conditions, to changes in the environment, are the key. So those animals that are better in adapting and basically perceiving the real world and adapting. So basically, if you see there is a lion and you run away very quickly, it's more likely that you survive. If you wouldn't have a perception mechanism that sees the lion, you're probably in bad luck and you will be eaten. So I think that's an interesting motivation which I see. And if you look at the human body, at animals, there's an interesting set of senses, and senses is not equal to sensor. So we have the sense of hearing. But there is, with the sense, it's often much more than just a sensor. It's not an audio input we have to our brain. We obviously get an audio signal, but there is a lot of processing and understanding which makes the sense. And that's the tricky part. So I think looking at human senses, at animal senses, I find very inspiring for thinking about digital systems that are adaptive. And obviously sort of the capabilities humans and animals have are very often far out, but nevertheless they're a good inspiration. And in other areas we get senses which humans don't have, so thinking of GPS, so that's another inspiration. What senses do we humans not have, what machinery or digital devices have, and how can we then augment our own abilities? And I think the navigation system is one of those examples where we augment humans with a further sense. And for a lot of people using it very often, this becomes sort of as an additional sense, also with the consequence that the other sense they may have for navigation without a navigation system may be may be lost in the end.
Mm-hmm. So they skip navigating when they're on the about to enter the highway. They go the wrong direction because
there are all these interesting urban myths where people drive in the canal or drive the wrong way off on the highway because they didn't even give a thought. Mm-hmm. But I think also probably everybody can try it themselves. If you drive with a navigation system, you probably have a hard time telling what towns you passed because you just follow what you are told. Mm-hmm. And obviously that's a risk with regard to user experience. And I think if we create context-aware systems, we should take into account that sort of the user experience should not sort of have a problem with the automatic part of the system. Obviously, we want to have systems where users feel in control. Mm-hmm. And again, the navigation system is something interesting. So the navigation system tells me walk this way, and when I walked here from the railway station to this place, I thought, oh, I want to walk along Kö, the nice shopping street here, and I just sort of took a turn, and obviously sort of the navigation system then rearranges the way, my suggestions, which way I should walk. And I think this is a nice design principle, so that we don't take control away, and that we follow this sort of very old ideal of augmenting the human, but leaving the human in control. Mm-hmm. And I think that brings us back to another design principle, which we also can then link to sort of perception in nature.
Thank you, Albrecht, for passing on your advice today. And if you want to know more, you should read the chapter Albrecht has written, and you can find this at interactiondesign.org. Here you can also find more chapters written by other thought leaders and inventors. And you can find more videos like this one as well. Thank you so much for watching.